Hi, my name's Aaron, and I'm really excited to be here with you in New Zealand to talk about the Naomi project and the state of speech recognition technology in open source. Now, the reason why I can't be with you today is because we are in the middle of a global pandemic and meetings are being canceled left and right because we are all trying not to spread germs. And that's one of the big benefits of a verbal interface is that there's no keyboard, there's no mouse, there's no touch screen to get for you to interact with the computer. You can use the computer, but you're not transmitting germs to anyone else who uses the computer. So there's a lot of good reasons to have a voice interface, and it pretty much is useful anytime that your hands or your eyes are involved in something else and you can't look up or put down and refocus. So, for example, cooking. If you need to change the program that you're watching or look up an ingredient or do a conversion right now on the computer in the middle of working on a recipe, you have to stop what you're doing, wash your hands, go use the computer, wash your hands again, and then go back to the cooking that you were doing. And this is, I do a lot of work with electronic medical records, and this is especially annoying to dentists who, if they want to look at a different x ray or pull up a different view of the patient's chart in the middle of doing something with the patient's teeth, then they have to put down the tools that they are working with, and often they are doing very precise work inside people's mouths, and they have to take off their gloves, throw the gloves away, wash their hands, change the electronic medical record, wash their hands again, put their gloves back on, and go back to the patient, all of which just takes a couple of seconds, but when you're sitting in that dentist chair with your mouth open, every second feels like an eternity. So there's a lot of different reasons why it's really helpful to have this kind of an interface. Um, Unfortunately, there are some problems with the way that it's being sold right now. Commercial assistants are trying to sell you on this idea, this false dichotomy that says that in order to use a verbal interface, you have to do everything in the cloud. Um, when I was growing up, this was kind of a verbal interface robot. And these robots, as far as I could tell at the time, are pretty much self contained. They aren't constantly accessing some larger computer system. They just understand what you say and are kind of a self contained system. The goal of the smart speaker companies is right now to dominate the market. The idea is that if you become the dominant smart speaker virtual assistant software, then device manufacturers will go out of their way to make their software compatible with your device. And also, consumers will want to buy your device because it's compatible with the things in their home. And so the device manufacturers really want to insert themselves between you and all of your stuff or all of the technology that you interact with on a daily basis. Your lighting, your air conditioning, your refrigerator, your coffee maker, and even your toilet. So, if you designed a speech assistant that you needed to work in order to flush your toilet, your goals would be reliability and security. Really don't want to be broadcasting all over the internet every time that you need to flush your toilet, and you want your toilet to flush every time, which is different from the goal of these smart speaker developers, which is really to collect information about what exactly you are doing. So here is a chart that shows relative um, adoption rates compared to other technologies that have come out recently. The smart speaker, 4 years ago, there was a smart speaker in 1/4 of American homes. 3 years ago, it was a third of American homes. And I don't think that it has quite kept pace with what they were predicting here, but I think that that really has to do with the fact that people are starting to get concerned about security. So the public, I took a couple of quotes from this article from The Atlantic because they do a good job of kind of explaining to me how the public is thinking of things. So it says these speakers possess artificial intelligence. Well, the smart speaker itself is more like a telephone receiver, and it's just kind of an open phone call to a server someplace. Um, and that's why they need an always on internet connection. I know that you guys understand this, but I think a lot of people were kind of confused about this just based on last year, the number of people who seemed to be genuinely shocked when it turned out that smart speaker manufacturers like Amazon and Google and Siri were sending out audio files of what customers had said to their smart speakers to be hand transcribed by human beings to help improve the speech recognition software. So this is kind of how the smart speaker is being sold to us, and how I think most of us expect them to work is that there's this device in your house and you talk to it and it figures out what you're asking and it makes a request to the internet and gets the information back and transforms that information into um, a response. But how they actually work is that there is a server. So your speaker, again, is more like a telephone receiver, and you're just talking to the server. It does all of the processing of your voice and then services your request and then sends you back a response in the form of a wave file or some kind of media file, which then it's able to take and play back to you to give you your response. And it all happens amazingly fast and invisibly. But basically, this is what's happening. And this server up here makes a fantastic place to keep track of everything that a person is doing and really build up a pretty detailed analysis of who they are. What sorts of things are they interested in? What when do they get up in the morning? When are they gone during the day? What sorts of things do they discuss? How many people are in the house? Um, when are they turning on lights? When are they turning on the coffee maker? That sort of information is invaluable to advertisers and others who want to control your perceptions and your opinions and just influence what you're doing. So, I wanted to talk briefly about some open source assistants other than Naomi and how they stack up. The first one that I want to talk about is Mycroft, which is probably the biggest system that you're likely to have heard of. There's been a lot of articles in different open source magazines and stuff that talk about how to set this up and how it works and all of that. So it is very simple to set up. You basically just download a file and run it. It is compatible with a lot of home automation um, services like Home Assistant and Node-RED. And but what you need to understand is that it's still doing voice recognition and speech generation in the cloud. So here's my diagram of how this works. It's a little bit more complicated than any of the other diagrams, and this is just my understanding, but I think you can see why I'm still a little skeptical of this system. When you talk to your speaker, it's still acting basically like a telephone in that it sends the wave file up to the server. The server then communicates with Google speech to text, and then it returns the text that you said back to the speaker. The speaker itself actually does the intent parsing, um, which I'll talk about in a second, and then sends a request out to another service, or maybe it can just, if it's something that the computer just knows, it can just handle it right there. But if it needs to contact another service, it does that, and then it sends a text message, a text string to the Mycroft server, which then converts it into a WAV file, which then the speaker is able to play. So basically, while they say, okay, we respect your privacy, and they probably do, they still get a copy of the the WAV file that you are sending out, and they also get they're also creating the WAV file that's being used for a response. So they know what you're requesting and when and what the response is. Um, so this is better than having all of these services contacted um, by the server itself, but there's still room for improvement. Now, one of the things that they say about doing the speech to text processing this way is that by going through their server, it kind of anonymizes your data so that Google doesn't know the IP address that um, your speech file is coming from. But as speaker recognition becomes more advanced and looking at the way that face recognition has really taken off in the last couple of years, doesn't seem like that's going to be a valid argument for much longer. So next we have Raspy. This is a system that I have not really tested myself. It seems like it's pretty well documented. It works with CodeRed, Hass.io, and Mozilla Home Assistant. It's on the MIT license, so you could fork it and remix it. And but it seems to use pre-built models for the speech processing. So that would be my only fault with that system, but it appears to do the speech recognition and all of the processing on the machine, unless you're using um, a cloud-based service directly. Um, Almond seems to be more of a chatbot. It's open source, but I've been having trouble really figuring out how to read the source code. It works with Mozilla Home Assistant, and it is an application for GNOME Desktop, which is probably how I would use it. Um, on Android, who knows what it's doing, but I'm not really an Android developer. Then we have Jasper, which is plugin based. It's 100% Python. The source code is available and it's pretty straightforward, but development stopped in 2017. The story that I've been told is that the original developers for Jasper got jobs at Microsoft working on the Cortana project. I don't know, um, how correct that is. But then there's Naomi, finally. Naomi is based on the Jasper Dev branch of Jasper, which was their next generation Jasper um, device software. It is 100% Python. It is simple and it can be set up to do everything on your device. So the way that Raspy and Naomi work is pretty much the way that one would expect these services to work, is that you talk to the speaker, it records what you're saying, it turns that into an intent, it services that intent directly with whatever web services it needs to go to, and then it creates a response locally and sends it back to you. So let's talk about the parts of a voice assistant, which are basically just speech recognition, then figuring out and handling the intent, and then speaking a result back to you. So, speech to text is a type of speech recognition engine that responds to speech with a transcription. And here are some of the more popular speech text engines. Caldi, Pocket Sphinx, and Mozilla Deep Speech can all currently be used by Naomi. Caldi is difficult to set up because it's really more of a toolkit for people who are researching speech recognition technology. So it's very theoretical. It's more like a Lego set for putting together a speech recognition system. But there are pre-trained models out there that you can use, and it seems like it's becoming easier to use over time. And there is a great deal of flexibility in what it can do. So I'm personally exploring Caldi at the moment and very excited about the possibilities of what we'll be able to do with it. Pocket Sphinx is very fast because it uses basically statistics rather than a neural network to figure out what the sounds mean and then put those sounds together into sentences. The secret to Pocket Sphinx is that it's really good at recognizing what you say if you can create a dictionary with the right number of words in it, the right variation of words. Um, because if the dictionary is too big, it can have trouble figuring out what word to use. And if your dictionary is too small, it will still try to interpret everything that it hears as something that is in the dictionary. Mozilla Deep Speech is slow. It could take a couple of seconds to do the speech recognition, at least on my hardware. I do not have a CUDA compatible video card to experiment with, so it takes a couple of seconds. I think you can get that down a lot by running it on better hardware. It can be difficult to install. It requires that you use a Google build system um, to install it, and that in itself can be difficult to set up. It also uses a non-standard version of TensorFlow, and it's based on Baidu's deep speech. So the basic flow of what they're trying to do is available in a white paper. And Paddle Paddle Deep Speech is the same thing, and it's based on the same paper, but this one uses a standard Paddle Paddle engine, which may make it a little easier to set up. And then there's Wave to Letter plus plus, which I have not actually tried, but it appears like it's about the same idea as these other ones, and it's from Facebook. It's kind of a newer system, so that could be an interesting thing to look into. Um, so once you have your speech parsed into text, then you have to figure out the intent of what it's trying to do. And there's a bunch of different intent parsers. Adapt and Presentation are both products of the Mycroft Foundation. Um, Fuzzy Wuzzy uses edit distance, which just means it tries it figures out the minimum number of changes that have to be made in order to match another string, and then it whatever has the shortest edit distance wins basically. And then there's Fisticuffs, which is faster, but it's a little brittle. It requires that words appear in a particular order in order to match. And finally, up at the top here, we've got the Naomi intent parser, which is also based on edit distances and weighted keywords. And I'm currently working on that and still trying to figure out the best way of matching stuff up, especially because you're not getting a perfect transcription from the speech to text um, engine. Finally, we've got text to speech, which is what returns your answer to you. Um, my favorite run right now, the easiest one to set up, is Flight, which is based on Festival. It's basically Festival Lite. Festival has a lot more tools for controlling the inflection and the tone of speech. So you can animate this better. eSpeak is, I find it almost unlistenable, and if anybody has any suggestions on that, I would appreciate it. It's a very lightweight library, and it's available by default with most Linux distributions, but it sounds like a Dalek when it's talking to me. Then there's Mary TTS, which is a much more advanced and lifelike sounding text to speech system. It has a limited number of voices, more limited than Festival. Um, and it requires more hardware, so it won't run on a Raspberry Pi, or at least not a Raspberry Pi 3, and I haven't tried installing it on a Raspberry Pi 4 yet. But it's kind of resource intensive, so you need to have a um, a server in your house someplace, preferably a desktop that's able to work with that. And then you've got Mimic, which is the text to speech engine that Mycroft uses, and uh, so it's what they run on their server basically.
So I want to do a demonstration for you guys, but I wanted to show you this first. This is my chart of the trade-offs between accuracy, speed, and dictionary size. As speed goes up and dictionary size increases, accuracy goes down. So what I have found to be the best for myself is to go for high speed, small dictionary size, as small of a dictionary as possible, and kind of middle of the road accuracy as far as what you're getting back. You usually get enough words correct for the computer to be able to understand what you're trying to tell it. And a lot of that happens in the text to intent parsing. So I wanted to do a demonstration for you right now. And so I'm going to pull up the terminal. There we are. It shows you the options that can be passed to the interface. Right now, all of it's only a command line interface. We'd love to have some kind of a web interface eventually, and we're working on doing an API for the Naomi server so that then you can run a web server that would connect to it on the back end. And make some of this stuff available to you through a web interface, which would probably be, which I would say would definitely be easier to work with. So there's a lot of debugging options. There's a bunch of options for saving audio, different types of audio, which you can then use to train your own speech-to-text engine. Then there's some things that affect the way that Naomi works, like listen while talking, which allows it to listen while it's talking, which works well if you have a microphone and speaker that are connected together that do echo cancellation at the hardware level, so it doesn't actually listen to itself. Or you can use headphones if you want. It allows you to stop Naomi from talking while Naomi is talking. So if it misunderstands something, it goes into a long, giving you the weather report when you wanted the news or something, you can say stop and it'll stop. And then these all have to do with plugins that people have submitted to the Naomi project. These are actually hosted on their own servers, and so this is just a nice way to be able to share plugins that you have written with other members of the Naomi community. And there's an actual store file. This process of submitting plugins, that could be really improved, and I'd love to see somebody take that on. But if you actually list the available plugins, you get something like this. This is just a few that people have written to test this system out. And so I also wanted to do a live demonstration of Naomi itself.
My name is Magic Voice. How can I be of service?
Magic Voice, what time is it?
It is 12:38 p.m. right now.
Magic Voice, shut down.
Goodbye.
So these are pretty simple requests, but you can see it did a pretty good job. And this is using just the Pocket Sphinx engine. And it has been trained to my voice. And let me show you how that works also right now. There's a program called Naomi Speech to Text Trainer here. So you start that up, and then you pull that up. Okay, here you go. And this is a list of things that Naomi has recorded, and there's a bunch of options here. You can say the transcription is correct. You can correct the transcription. You can say it's just noise with no voices, and that actually helps train the voice activity detection so that it ignores noises. And then there's you can tell it who is speaking, and you can also verify the intent. So let's listen to what I said. And it got the transcription correct in this case. And the speaker was me. And it got the correct intent also. So I'm going to go ahead and submit that. Oh, actually it didn't get it correct. The transcription is actually, so let me stop that. The transcription is actually Naomi, what is in the news. So it missed a word, but it didn't affect the outcome. Okay. So, and then here is, again, Magic Voice, what weather forecast. I'm sure I probably said, what is the weather forecast?
Magic Voice, what's the weather forecast?
Okay, what's the weather forecast? And this is something that can be, that needs to be worked on right now, too, is right now these contractions are not being expanded out. We really need to, in both the intents and when it's trying to process something that somebody has said to it, it needs to expand out that what's into what is in order to do better matching on the actual intent. But it did get the correct intent, and so all I have to do is hit submit. This last option down here, this was not directed to Magic Voice or was too unclear to understand. That basically is just a garbage can. So it doesn't affect anything. It basically just ignores those things. So anytime there's a command that you don't want to actually train Magic Voice on, you can just hit that and it'll ignore it. So I'm going to submit that, and then I'm going to go over here to train speech-to-text engines. Now this looks like I was probably talking to somebody else and it just picked up what I was saying. It's passive transcription, so I made enough noise that it was hearing what I said. But anyway, this kind of gives you an idea of actually what's going on with the tech companies and why they are sending out these voice files to people to be hand transcribed. So this is where you would have a whole list of different trainers for speech-to-text engines. Right now, the only one that's available is the Adapt Pocket Sphinx. So it takes one of the standard Pocket Sphinx models, and right now English, French, and German are the only ones that are available. I'd love to expand that out, especially to Spanish, but there's a lot of work to be done in training it for different locales, different voices, etc. So I'm just going to hit this button and go ahead and let it do the training. So out of the 1,200 or however many recordings I had, it's only actually using 283 of them to do this training. So that's a great way of improving the recognition. So I hope that gives you some ideas about how voice recognition works, and the current state of the technology and how you could help. We're always looking for help. We really value contributions, and I will personally say right now that if you want to submit anything, a pull request or a question or a suggestion or anything, I will be on it and I will be responsive. And I'm really hoping for help on this. And help doesn't have to just be programming. Help could just be letting us know when something doesn't make sense, when the documentation is wrong. This has been a fairly fast-moving project, so documentation falls behind sometimes and we forget that we haven't updated stuff. The documentation itself is actually on GitHub, so it can be edited directly through the Naomi project / Naomi docs. Repository. And actually, let me go ahead and just show you. So this is the Naomi website, and there's a support area over here with a bunch of different options for communicating. There's a knowledge base, there's a forum, we're working on some video tutorials. Then there is also under the GitHub page. So Naomi is the main repository for these things, and you want to be using the Naomi dev rather than Naomi. Naomi is the master branch for Naomi right now is pretty old, and we're looking forward to doing the next release, which we're calling Naomi 3.0. So I really recommend that you go for instead of master, go for the Naomi dev branch, which will hopefully become the master branch soon. But this has a lot more activity on it.
As far as the documentation goes, there are also two repositories, or two branches, I'm sorry. There is master, and then there is dev. And so master corresponds to kind of the stable release, which, like I said, is pretty old at this point, and dev is where all of the new documentation is being put in, and that corresponds to, if you're on the website under documentation and you go further than the first page doesn't have this for some reason. Once you go into here, then you can switch from stable to dev, and so now you can see that there's some additional documentation that has come in at this point, um, because it corresponds to the latest version of the software, which has a lot more going on. Um, very excited about this. Anyway, that's pretty much my presentation. Let me just switch back to the presentation itself. So here are some references. These are things that I reviewed in order to put together this presentation. I especially would encourage you, to check out the latest copy of Make Magazine. That's volume 72, which has a fantastic article that goes over a lot of the theory behind this and talks a lot about the different open source um, voice assistant systems. And so this is really a plea for help. I'm really looking forward to you guys participating, and I'm going to make a commitment right now to being responsible, to respecting your time and your submissions. If you have a suggestion, if you have a question, if you're trying to figure out how to install something, if you want to suggest a way to make things better, if you actually write something and have a pull request, that would be great. If you want to update the documentation, that would be awesome. Anything that you guys want to do, I will personally react to it and make sure that your time and effort is respected. Anyway, that's the end of my presentation, and I will be scheduling a live YouTube feed at the time when we were supposed to meet originally at the meetup. So if you guys have questions or things that you'd like to go into more detail about, I'm happy to talk to you then, and I'm available um, by email. I'm available on the Naomi website, and I look forward to hearing from you guys. Thank you.